Bismillahirrahmanirrahim. I am Zara Batul and the other presenter is Mariam Batul. Today we are going to discuss the applications of titration in cleaning agents. Basically, we will discuss the determination of different compounds in cleaning agents using titrations. Concentration and acidity in cleaning industries. The industries manufacturing cleaning products use acid-based titration to determine whether or not cleansers remove bacteria from a surface. Through titration, it is possible to identify which cleaning product has level of acidity that is required to kill bacteria. So the titration kits are used to define the appropriate concentration of chemicals in a sanitizer or cleaning agent. Determination of hydrogen peroxide in sanitizers and disinfectants. So it is basically the redox titration which is used for the determination of hydrogen peroxide content in sanitizers and disinfectants. Hydrogen peroxide is a chemical compound with a strong oxidizing capabilities. It acts against a variety of microorganisms including bacteria, viruses, fungi, yeast, spores. It has been utilized in several formulations of bleaching agent, disinfectants and sanitizers. Hydrogen peroxide concentration. The concentration of hydrogen peroxide differs according to the objective of formulation. It is not same in all of its applications. Like the 3% of the hydrogen peroxide is used as a potent disinfectant. 0.5% is effective against surface viruses, and the low concentration is used to terminate bacterial spores in the solution. For this application, hydrogen peroxide content is established with the redox titration method utilizing cerium sulfate as a titrant. Materials required: sample, disinfectant and sanitizer with respectively 3% and 0.1 to 5% of the hydrogen peroxide content. Titrant is the 0.1 molar per liter cerium sulfate, and the other chemical used is the concentrated sulfuric acid that acts as a buffer and maintain the specific pH like acidic pH in the solution mixture. So here is the procedure diagram for the process in which we have a thermostable beaker. The thermostable beaker have the disinfectant or the sanitizer sample that is connected to the thermostable beaker that is connected to the thermostat that controls the temperature during the reaction, and that thermostable beaker is connected to a automated titrator that supply the required amount of the cerium sulfate, and there is also a stirrer in the setup. This all of the setup is an automated titration, and the all setup is connected to the computer that have a software which help us to draw the titration curves. Procedure steps. So the procedure step, the first step is the making of the 5% of the sulfuric acid. For that we add 25.50 milliliter of 98% sulfuric acid into a 500 milliliter volumetric flask that contain approximately 150 milliliter of deionized water, the water that doesn't contain any impurity and ions, because the impurities and ions disturb our results. Then we add 40 milliliter of 5% sulfuric acid into the thermostable titration beaker, and this thermostable titration beaker we add 0.2 milliliter of the disinfectant sample, and in case of sanitizers we add the 5 milliliter of the sanitizer sample, and we titrate it against the standardized cerium sulfate that is 0.1 mole per liter. So here is the chemical equation for the reaction in which hydrogen peroxide reacts with the cerium sulfate to form the cerium sulfate, sulfuric acid and oxygen. The only difference between the reactant and the product side cerium compounds is that in the reactant side cerium has the oxidation state of +4 and it is reduced to oxidation state of +3 in the Ce2SO4 3. So basically cerium sulfate is an oxidizing agent that oxidizes hydrogen peroxide to the oxygen and reduces itself. So it is a redox titration. Now discussing the results for the application. The hydrogen peroxide content was determined and the process was repeated many times, and the mean value for the disinfectant, the mean value of hydrogen peroxide percentage for the disinfectant was 2.969, and the sanitizer it was 0.122. So the hydrogen peroxide content in disinfectant and the sanitizer sample is established, and the values acquired by redox titration with cerium sulfate are in sound agreement with the content of hydrogen peroxide anticipated in both samples. So the method is accurate for the determination of the hydrogen peroxide content in the disinfectant and the sanitizer samples. Next, Mariam will discuss the another method for the determination of hydrogen peroxide in samples.
And that is by redox titration with potassium permanganate. The concentration of hydrogen peroxide can be analyzed by redox titration with potassium permanganate. The permanganate ion acts as an oxidizing agent because it causes the oxidation of hydrogen peroxide. The oxidation half reaction shows that 2 electrons are lost per molecule of hydrogen peroxide that is oxidized to oxygen gas. As we can see in the reaction that hydrogen peroxide is being oxidized to oxygen gas. In turn, the permanganate ion is reduced from the +7 oxidation state in manganese oxide to the +2 oxidation state in manganese, and the reduction half reaction shows a gain of 5 electrons. The apparatus which will be used for this titration is a 250 ml volumetric flask, pipette, burette and retort stand, conical flask, a beaker, a filter paper and a dropper. Chemicals used for the titration are standard potassium permanganate, hydrogen peroxide, distilled water and dilute sulfuric acid. Procedure of the titration: first of all, obtain about 75 ml of potassium permanganate standard solution in a small beaker. Rinse a clean 50 ml burette first with water, then with two 5 ml portions of potassium permanganate solution to avoid the impurities. Then clamp the burette to a ring stand using a burette clamp and place a waste beaker under the burette. Fill the burette with potassium permanganate solution until the liquid level is just above the zero mark. The next step in the procedure is that using a volumetric pipette, transfer 1 ml of the commercial hydrogen peroxide solution into a 125 ml earthenware flask. Add about 25 ml of distilled water to the flask. Measure 5 ml of 6 molar sulfuric acid into a graduated cylinder and carefully add the acid to the solution in the earthenware flask. Gently swirl the flask to mix the solution. Position the flask under the burette. Then we have to open the burette stopcock and allow 5 to 8 ml of the potassium permanganate solution to flow into the flask. Swirl the flask and observe the color changes in the solution. Continue to add the potassium permanganate solution slowly, drop by drop while swirling it, and when a light pink color persists in the titrated solution while swirling, the endpoint has been reached and it indicates the presence of hydrogen peroxide. The next application of the titration is in the determination of properties of bleach. Redox titrations are used for the determination of available chlorine in bleaching powder in hypochlorites. We have to determine the amount of hypochlorite ion because the hypochlorite ion is the active ion that is responsible for the bleaching purpose. So for the determination of the amount of hypochlorite ion, it is reacted with the iodine ion, and as a result of which chloride ion is formed along with the iodine. So as the iodine is formed, in the next step this iodine is again titrated with the sodium thiosulfate solution, and we can determine the concentration of iodine. The concentration of iodine indirectly tells us about the concentration of hypochlorite ion. That's why it is a back titration, and we can determine the amount of hypochlorite ion from the iodine ion concentration indirectly. Next, if we talk about the procedure of the titration, we have to weigh out accurately about 5 grams of bleaching powder. Grind this bleaching powder, add distilled water to form very fine suspension. Then this fine suspension is added to 250 ml conical flask and 25 ml of water is added. 2 grams of iodate free potassium iodide and 10 ml of glacial acetic acid is added. Then we have to titrate the liberated iodine with standard 0.1 molar sodium thiosulfate. And so by this procedure we can determine the amount of hypochlorite ion from the iodine ion concentration indirectly.
The other property of the bleach is the alkalinity of bleach. Now we will see the application of titration to determine the alkalinity of bleach. Determine the alkalinity of bleach using acid-base titration. Household bleach is actually a mixture of chemicals. Its main constituent is a solution of 3 to 6% sodium hypochlorite, which is mixed with small amounts of basic products such as NaOH and sodium carbonate. The alkalinity of bleach is determined using acid-base titration. The hydroxyl ion content is simply determined by an acid-base titration using a strong acid as a titrant. So the titrant solution is sodium hypochlorite solution. Titrant is 0.1 molar HCl solution. Additional agent is hydrogen peroxide. Analyte is hydroxyl ion by finding sodium hydroxide, and indicator is starch solution. So here are the procedure steps for the reaction. First of all, pour 80 ml of distilled water into a beaker and then add 4 ml of the sodium hypochlorite solution in it. Then add drop by drop 30% of the 5 ml hydrogen peroxide to destroy the active chlorine contained in the sodium hypochlorite, because the active chlorine interrupts our process and disturbs the results. So next, titrate the solution with the HCl, that is the 0.1 mole per liter, to the second equivalence point. Diagram. So starting from the left side of the process diagram, the first apparatus is for the preparation of samples. The sample is the sodium hypochlorite, so apparatus is used to prepare the sodium hypochlorite samples with the equal concentration. Then after that, to the sodium hypochlorite sample solution, hydrogen peroxide is added to destroy the active chlorine, and in the next setup HCl is added to obtain the two equivalence points, and all of the setup is connected to the computer to draw the titration curve and also to calculate the concentration of hydroxyl ion. So results. When the sample is titrated with HCl, two equivalence points are obtained, the first of which correspond to sodium hydroxide and the second is to the sodium carbonate. However, per definition, the total content of free alkali is given as NaOH. So NaOH content give us the content of the free alkali in the bleach. That's all from the application of the titration in the cleaning agent. Thank you.